Hello, good evening. This is another day. I want to welcome you back to our class. So before we embark on this work, I want to thank you so dearly for your support. Continue watching, subscribing, and sharing. God bless you. So today we are looking at propagation of errors. Remember, this is lesson number 2, a continuation of what we learned from our previous lesson. Today we are going to find or determine the percentage error in division. So I'm not going to start by showing you on how we find the absolute error, how we find the relative error, how we find the percentage error. We are going to follow that particular content from our previous lesson so that now we can go direct to an example. So you will see me saying example. Find the percentage error in, you might be given numbers like 24.394. You are dividing it by 0.048. So those are two numbers that are being divided. So we will now say solution. Where we start from is finding the upper limit of each given number. Finding the upper limits of each given number. So look at the first number. We are having 24.394. What will be our upper limit? So we must obtain the absolute error. So we will say our absolute error is equal to a half times this one being our number, we say 0.001, 0.001. Half of 0.001 becomes 0.0005. So this is what we add to 24.394 to get the upper limit. So in this case, when you add, you will obtain 24.3945. When you subtract the 0.0005 from 24.394, you will obtain the lower limit as 24.3935. So that this is our lower limit. So let's go to 0.048. How do we obtain the upper and the lower limits? We must first start by obtaining the absolute error, which is a half times, this will be 0.001. 0.001. Half of which means 0.0005. So that becomes our absolute error, of which we should add it to 0.048 to get the upper limit, which will give us 0.0485. Lower limit, we subtract 0.0005 from 0.048. We will get 0.0475. So that's our lower class limit. So we will start by finding the maximum value. The maximum value. So how do we get the maximum value? We look at the highest number obtained from these limits. This is the biggest or the largest number. So it will say 24.3945 divided by the lowest or the least number obtained. These ones are greater than these two. But between these two, which one is the least number? This becomes the least number. So we will now say 0.0475. we divide the 2. So we now have 24.3945. We are dividing by 0.0475. It is giving us 513.5684. So that's our maximum value. Let's go to the minimum value. Minimum value. Remember, we have used this and this one to get the maximum value. We now divide what the numbers that have remained. We take this number, we divide by this. So now we will have 24.3935 divided by 0.0485. As you can be able to see, there is a very big difference on how we determine percentage error in multiplication and in division. In division, we take the upper limits only, then we multiply them. Then we come and take the lower limits, then we multiply them. But in this case, there's some little difference, whereby you are seeing us taking the upper limit from the biggest number that we have here, then divided by the lower limit. Instead of the upper, we are dividing by the lower limit. So that's the difference. You take the upper limit, you divide by on the other side, you now pick the lower limit. Upper limit divided by the lower limit. But in multiplication, we took upper multiplied by the upper. And then we took the lower multiplied by the lower. So in this case, there is that difference of taking the upper divided by the lower, then the lower divided by the upper. So now this will give us what? We are going to have 24.3935 divided by 0.0485. It is giving us 502.9588. 502.9588. That's in the 4 decimal places. Now let's find the actual value, which will be 24.394 divided by 0.048. That is the actual value, 24.394 divided by 0.048. It is giving me 508.2083. That's if we give our answers into 4 decimal places. Now let's go to the absolute error, which is the same as maximum value minus the actual value plus the actual value minus the minimum value, then divided by 2. So our absolute error is going to be maximum value is 56.84. Then we subtract the actual value, which is 508.2083 plus 508.2083 minus the minimum value, which is 502.9588, and everything divided by 2. So our absolute error becomes, now we can subtract, we have 513.5684 minus 508.2083, whereby we are getting 5.3601. Then we add 508.2083 minus 502.9588. We are getting 5.2495 then divided by 2. So our absolute error becomes 5.601 Then we add 5.2495 divided by 2. I'm getting 5.3048. That is absolute error. We now find the percentage. The percentage error. That's our objective, finding the percentage error. Percentage error becomes the absolute error over the actual value times 100. And remember, absolute error divided by the actual value, it gives you the relative error. Relative error times 100 gives you the percentage error. Now this becomes 5.3048 divided by the actual value, which is 508.2083 times 100. So I will divide my answer by 508.2083. Then I multiply by 100, which is giving us 1.0438%. So that is the percentage error in dividing these two numbers. Thank you for listening to me. If you have a question, go to the comments, ask your question. I want to assure you that your question will be answered immediately. God bless you. Thank you for your support.